Hey guys, good morning. Today we're going to do pages 17 and 18 in your notes, Congruent Figures. This is going to be kind of just intro to the vocabulary terms, things like that. And then it's also going to be some algebra. So page 18 is where we're going to do all of the algebraic problems that you'll see more on the ACT and on your EOC and chapter tests. All right, so let's go ahead and get started. Congruent figures. Remember, we know what both of these words mean. Congruent means same size or same as equivalent. Figures are like shapes. So congruent figures are just shapes and figures that are the same. So congruent figures, they are shapes. Let me turn my light on. There you go. They are shapes that are the same size. It's basically like a copy and paste. So you copy the shape and then you paste it. It's like they're identical. Everything about them is the same. So for example, you can probably look at these and see, okay, yeah, those trapezoids are the same. But here's an example just using super big paper clips. So notice it's just like I said, okay, I'm going to copy this paper clip, paste it. Here's another one. Everything about them is identical. They're the same color. They're the same shape. They're the same size. Everything about them. And also notice how this like point right here corresponds to the same point on the other shape. I almost said triangle. This is not a triangle. It's a paper clip. Now, it doesn't matter if they're turned the same direction. I can take this right paper clip and rotate it 90 degrees. They're still the same shape. I can continue to rotate it. I can flip it. They're still identical. I can rotate it this way. You know, there's a lot of things you can do with these shapes, making them the same. Basically, I'm just performing transformations. I can reflect, I can rotate, I can slide it. These are still the same. Now, the way that we match things up when it comes to congruent figures is based on a congruency statement. So a congruency statement is how it tells you one shape is congruent to another shape. When it's kind of, you know, looking like paper clips, kind of like this, it's easy to match some things. Like you can kind of visualize, okay, this part's the same, and if I turn it, I can easily match, okay, these parts are identical. But whenever you have other shapes, like this shape, a trapezoid, it's a little bit harder to do. So the congruency statement is your guideline to match what's equal. So let's go ahead and start. So we're going to talk about how important congruency statements are and how they help us match congruent sides and congruent angles. All you have to do is match based on the location of the letters. So angle A is listed first. So this is angle A. A is listed first. In order to correspond what A matches over here, you just look at the second statement. A is listed first. K is listed K is listed first. So A is congruent to K. It's going to drive me crazy. I have to white it out. So whenever I have a problem like this, I'm just matching up first and first. Those two must be equal. So for my first little angle pair, angle A is congruent to angle K. To continue this trend, you're just going to kind of go down through the congruency statement. V is listed second. P is listed second. Angle V is congruent to angle P. So for our next angle, we have V and P. Notice how all we're doing here is we're just matching up the orders, and I'm also sticking with the first shape first. So when we're listing these, I'm not flip-flopping shapes. I'm starting at the first shape that's listed and corresponding it to the second shape. First shape, second shape. So let's go ahead real quick and continue that trend. It's just a pattern. J is second, M is second. J is congruent to M. It's all about the location and where those angles are located. So angle J is congruent to, not segment. angle M. And last, you have R and D. R and D. Angle R is congruent to angle D. Congruent figures are all about matching, just being able to look at a statement and match it to a picture. Once you match the angles, all of this becomes a whole lot easier. Let's focus now on the congruent sides, because remember, this shape has been copied and pasted and then just kind of rotated, basically 90 degrees counterclockwise. Okay, so let's talk about congruent sides. The way that you name the congruent sides is you want to color match A to V. Segment AV will be congruent to the same pattern on the other trapezoid. So we went orange to green. The way we name the second one is orange to green. So segment AV is congruent to KP. They get 1 bar. Then we're going to kind of shift around. Green to yellow, so VJ is congruent to green to yellow, PM. And let's just kind of follow that around the trapezoid. Yellow to pink, we'll get 3. So JR is congruent to yellow to pink, MD. And lastly, we have pink to orange, so RA. We will put 4 bars here. And RA is congruent to pink to orange, DK. We'll put 4 here. Now, you can use the picture to match the congruent sides, or you can also use the statement. So the main function of the statement is just to tell you what is equal. So based on our statement, we can use single letters to represent angles. A is first, K is first. Angle A is congruent to K. You can also utilize this congruency statement to match up congruent segments. So let's kind of focus ignoring our picture completely. AV. Let's see here. Let's see if I have a Post-it. I don't have a Post-it, but I have a Purell wipe in my bag from Chick-fil-A before they close. So let's pretend AV is listed first. So notice if we cover AV, that's the name of a segment, A to V, which is exactly what we wrote over here, AV. If we go to the second statement and just focus on the first 2 letters, we get KP. KP is what AV is equal to. And when we look over here, AV was congruent to KP. So if you're looking for angles, you only want to look at single letters. If you're looking for segment names, you want to look for the letters that are side by side. So AV is congruent to KP. VJ is congruent to PM. JR is congruent to MD, which is exactly what we've written here. Now, the tricky part is when you just get to the end. So for example, R has nowhere to go, but we haven't matched the last to the first yet. So RA is congruent to DK, which is exactly what we wrote. So remember, the congruency statement is more than just a bunch of jumbled letters. Using single letters, you can find the angles. Using double letters, you find the segment name. All right, let's go ahead and practice. Let's write some congruency statements for each of these pairs. First thing you always want to do is make sure that you are matching angles first. Okay, match your angles first. So I'm going to just kind of highlight them around. So C and D. Notice how they both have single curves, making those congruent. Then we have E gets double and F is double. And then we have A and B as our triples. You may name the first shape however you want to. The first way you name it, it doesn't make a difference, as long as you name the second shape in the same pattern. So let's just start 1 to 2 to 3. So triangle, C, E, A is congruent to triangle. And then once you establish the pattern on the first, you have to write the second one in the same pattern. So you can write your first pattern however you want to, but once you establish the pattern, the second triangle name must follow the same pattern. So we're just going to look. Okay, we went C, E, A, C down to E, up to A. The second triangle must follow the identical pattern. So we went yellow, green, orange. Yellow, green, orange. So triangle CEA is congruent to triangle DFB. That's one way to write it. Now, we're going to practice this a bunch of different ways. So let's go ahead and go through this, and we're going to move a little quickly. Obviously, we were supposed to do these notes in person, so we would be doing independent practice. But since we can't do that, we're just going to kind of talk through it together. Next, I'm going to go ACE. So triangle ACE is congruent to triangle, and notice your pattern, orange, yellow, green, orange, yellow, green. Triangle BDF. All right, last one. Let's start at E. We'll go counterclockwise. E, C, A. So green, yellow, orange. Hop on over. Green, yellow, orange. Triangle F, D, B. Now the same pattern exists for all of these practice problems. We're basically just matching angles and forming a circle. So this one is a little trickier. I'm going to start at A. Notice how to make angle A, you have a single bar and a double bar. The angle that's congruent to A will follow the same pattern. Single bar, double bar. So H must be our matching angle. Sometimes it's okay to use segments to guide you. All right, to make angle D, we have a double and a quadruple. Double, quadruple. B. Use what's around the figure to guide you in your problems. All right, C, single and triple. All right, to get to C, we got a single and a triple, so that is G. By default, that leaves us with F and E. Triple, quadruple, triple, quadruple. Okay. All right, so I'm just going to write any kind of pattern I want to. This isn't a triangle, it's a trapezoid, so you just are going to list the letters. So I'm going to do CADF. So CADF. So I went orange, or green, orange, yellow, pink. Green, orange, yellow, pink. So is congruent to GHBE. Let's make another one. I'm going to start at F. FCAD is congruent to, so notice how I went F is pink to green, so I'm going to do pink to green and just follow in the pattern. EGHB. One more. Let's start at D. We'll go counterclockwise. DACF. DACF. So yellow, orange, green, pink. Yellow, orange, green, pink. So is congruent to BHGE. Now notice it doesn't matter how we wrote it, but C is first, G is first. That must mean C is congruent to G. If we hop down to our next example, C is second, G is second. C is third, G is third. So notice it doesn't matter the order that I start the first one as long as I follow the same pattern. All right, for our last one, what we're going to have is a little parallelogram here. And the way we're going to match this, A and C will repeat because they're a part of both of the triangles. But in this first one, we have A here, and that is congruent to C over here. Notice the single lines. Then we have our double bars, which is A over here and C over here. These are alternate interior angles if the lines are parallel. So it's kind of like a parallelogram. And then by default, we have B and P, or B and P. All right, let's go ahead and try it. So PAC, so triangle PAC is congruent. So orange, green, yellow, orange, green, yellow, BCA. All right, let's try another. So triangle ACP is congruent to triangle CAB. So notice we just went green, yellow, orange, green, yellow, orange. All right, for our last one, let's start at C. CPA is congruent to yellow, orange, green, green. Triangle ABC. All right, in our next video, we'll continue.